Welcome to This Explainer. Today we're looking at what is absolutely the ultimate cosmic supply chain. I mean, the vast emptiness of space, it isn't just some lifeless void. It's constantly being enriched, populated, and transformed by these incredibly complex structures. And right at the absolute heart of all this creation are the stars themselves. Think of them as giant cosmic factories. Over billions and billions of years, they're manufacturing, forging, and ultimately releasing completely newly made elements out into the endless expanse of space, basically setting the stage for the whole shebang.
Okay, let's dive into this. We interact with complex matter every single day, right? But the universe didn't just start with all these complex building blocks perfectly formed and ready to go. No way. In the very beginning, just shortly after the Big Bang, the cosmos was mostly just this massive sea of basic hydrogen and a little helium. So you might be wondering, where exactly do the heaviest elements in the universe actually come from? Like, how do we get from a simple cloud of hydrogen to the incredibly diverse physical matter that actually makes up our world? Well, to answer that, we literally have to look up at the night sky and understand the incredibly violent, fiery lifespans of the stars.
To really wrap our heads around this cosmic manufacturing process, we first need to categorize the main actors in our story. Because, not all stars are created equal, and their destinies are entirely dictated by one absolutely crucial factor: their mass. On one side, we've got low to intermediate mass stars. Our own sun falls perfectly into this category, by the way. And then on the other side, we have massive stars. These are the true dominating giants of the cosmos. A star's mass dictates, well, everything about its existence. It determines its internal core pressure, how furiously it burns its fuel, its total lifespan, and most importantly for us, the specific types of heavy elements it's going to eventually gift to the universe upon its inevitable death.
Section 1. Winds and glowing shells.
So during their lives, particularly when they reach the giant phases of their life cycle, these low to intermediate mass stars undergo this just remarkable transformation. They don't just sit perfectly still in the dark. As the core contracts and the outer envelope massively expands during the red giant phase, the star gets kind of unstable. It actually begins to generate these really powerful pulsating stellar winds. Through these thermal pulses, the star is slowly exhaling its own atmosphere out into the void. And what is truly spectacular here is that these outer layers aren't just empty gas. Nope, they are heavily enriched with brand newly made elements that the star has been relentlessly cooking up deep inside its core over literally billions of years. Now, what exactly is in those exhaled outer layers? Well, the primary outputs of this specific stellar process are carbon and oxygen. These vital elements are actually born deep in the stellar core when helium atoms are forced to fuse together under just immense heat and pressure. Think about the profundity of that for a second. The very carbon that forms the fundamental basis of all life on Earth and the oxygen we're breathing right now are quietly breathed out into space by stars just like our sun as they enter their final giant phases. This beautiful exhalation basically culminates at the very end of a sun-like star's life. It completely expels its outer envelope, forming what astronomers call a planetary nebula. And these are majestic, glowing shells of gas just expanding outward into the cosmos. Through these glowing shells, the dying star is actively seeding space with what astrophysicists refer to as metals. Now, in astrophysics, a metal just means any element heavier than hydrogen and helium. It's really important to recognize that this is a slow, gradual seeding process over thousands of years. It's a peaceful release, gently returning the materials it spent its entire life creating back to the universe so they can be used all over again.
Section 2. The supernova explosion.
Now, what's really interesting about this next stage is how drastically the story changes when we start looking at massive stars. When a massive star reaches the end of its line, it doesn't just gently puff away its outer layers. No, when the core finally runs out of nuclear fuel, the outward pressure of fusion just stops, and gravity instantly wins. The star collapses inward at a significant fraction of the speed of light, smashes into the incredibly dense core, and rebounds into a catastrophic supernova. During this apocalyptic explosion, the star violently ejects its deep interior. The sheer force rips the star apart, hurling these extremely dense materials from its core outward at unimaginable speeds, spreading newly forged elements deep, deep into the surrounding galaxy. This incredible escalation of violence isn't just for dramatic effect either. It's physically required to eject heavier elements. The peaceful stellar winds of smaller stars simply don't possess the necessary energy. You see, up to iron, nuclear fusion actually releases energy. But creating elements heavier than iron, that's an endothermic process. It actively requires a massive input of energy
just to force the atoms together. The apocalyptic shockwave of a supernova provides exactly that required energy. It literally takes this catastrophic collapse to bring elements like iron, silicon, and many others out from the crushed core of a massive star and scatter them. Without this violent explosion, these heavier building blocks simply couldn't be formed or distributed.
Section 3. Extreme collisions and jets. Let's move forward and see how this builds into the absolute climax of our timeline. Because if you thought a supernova was the absolute limit of cosmic violence, well, the universe has something even more intense in store. To understand the origin of the absolute heaviest elements, we have to look at phenomena that push the very boundaries of known physics. As the research describes it, we're looking for collisions and enigmatic jets near black holes. Just let that sink in for a second. The universe's most chaotic, gravitational extremes are the required conditions for this final stage of elemental enrichment.
We are talking about events like neutron star mergers. Now, a neutron star is the crushed, dead core left behind after a massive star goes supernova. It's an object so incredibly dense that just a single teaspoon of its material would weigh billions of tons. That's about as much as a literal mountain here on Earth. When two of these ultra-dense remnants spiral into one another and finally collide, or when extreme tidal forces tear matter apart on the very edge of a black hole, they act as the ultimate cosmic forge. The conditions here are so blindingly intense that they produce the absolute heaviest elements in the universe, elements that even a standard supernova explosion just isn't powerful enough to create. And just like the previous stages, these extreme events blast these massive atoms far and wide into space.
So the crucial point is that when you look at heavy, complex elements like gold and uranium, you are looking at the direct aftermath of the most extreme cosmic violence imaginable, a neutron star collision, or a chaotic, relativistic jet tearing through space near a black hole. That is the specific origin of these materials. Every single ounce of gold in a piece of jewelry or uranium in a reactor was forged in an environment of unimaginable extremes. Actually, take a moment to let that realization truly set in. And this brilliantly illustrates our entire journey today. When we stack these cosmic events side by side, we see this perfect logical escalation of cause and effect. We start on the more peaceful end, with winds and nebulae from low to intermediate sun-like stars, which slowly seed the galaxy with carbon and oxygen over thousands of years. Then, scaling up the energy, we need the catastrophic core collapse of supernovae from massive stars to violently forge and eject heavier elements like iron and silicon. And finally, we reach the maximum physical extreme, the unimaginable density of neutron star collisions and black hole jets, which are literally the only environments capable of forging the heaviest elements of all, like gold and uranium. Which brings us to our final thought. Look around you right now. Look at the device you're watching this on. Look at the complex materials surrounding you. The stellar cycle of elemental enrichment isn't just some abstract concept happening millions of light years away in the dark. No, it is the fundamental shared history of everything you can touch, see, and interact with. You are quite literally made of star stuff. So I'll leave you with this question to ponder today. Which cosmic explosion created the specific elements you're interacting with right now? Thank you so much for joining me in this explainer. Keep wondering, and I'll catch you next time.